So children, in today's class we are going to revise the refraction of light. We all know that light travels in a straight line and it is the form of the energy that produces the sensation of vision. So light travels straight line. So इसीलिए तो बच्चा पढ़ पा रहा है. ठीक है. Yes, because of the rectilinear propagation of light, we get refraction of light, reflection of light. हाँ? तो रिफ्लेक्शन ऑफ लाइट जब होता है तो एक ही मीडियम में लाइट वापस आ जाती है, लेकिन जब हम रिफ्रैक्शन की बात करते हैं तो रिफ्रैक्शन में लाइट एक मीडियम से दूसरे मीडियम में जाता है. ठीक है. एंड व्हाट हैपेंस, हाउ इट हैपेंस, how do I measure the bending of the light is all the topic which we are going to study today, right? Okay, so let's go. Refraction means the change in the direction of the propagation of a ray of light when it travels obliquely from one medium to another transparent medium. Suppose I have got air as the first medium and glass as the second medium. You can see that the incident ray comes in a direction PQ, now falls on the air and glass interface out here, and then it travels with the denser medium along the ray that is Q से लेकर के R तक, and then again it meets the medium air and travels in the path of R as, and it is called as the emergent ray. So we can see that the first ray PQ is the incident ray, QR is the refracted ray, and R outwards it is called as the emergent ray. So originally PQ को ऐसा सीधा जाना था, लेकिन because of the glass medium out here, it has gone from P to Q, Q to R, and then outside as an emergent ray. The original path of the ray and the final path of the ray are parallel to each other. Okay. Now, rarer से denser तक गया. That means the first is air and the next is glass. So if the light travels from a rarer medium to denser medium, it is bending towards the normal. Whereas from glass to air, it is traveling from the denser to rarer medium, so it is going away from the normal, right? So हम ये देखते हैं कि if the light is traveling from a rarer to denser medium, it will go towards the normal, and if it is going away, then it will be denser to rarer, then it will go away from the normal as shown in the diagram. Okay, now what is the angle of incidence? The angle between the incident ray and the normal at the point where the ray meets the interface between the two medium, it is called as the normal. The angle between the incident ray and the normal is called as the angle of incidence. And what is the angle of refraction? It is the angle between the refracted ray and the normal, and it is represented as R. Okay. Now, the angle between the emergent ray and the normal, it is called as the angle of emergence. Now, the question arises, why the refraction takes place? So, I am going to take an analogy of a tractor which is moving on the smooth road, and here we have got some rough places just besides this road. Now, see, the tractor is coming in the straight road, and we are going to understand why light bends by this example. Tractor is moving, and while it is moving, I am going to make it turn, and while it turns and goes into the rough surface, the speed of course will decrease. Right. Now what happens is, let us talk about the right wheel and the left wheel. Speed जो right wheel का है वो कम है, and the speed of the left wheel it is more. So when it travels in such a way, it bends and follows a path like the one which is shown in the diagram. Right. Okay. Now what happens in the conclusion we can draw? That means tractor bends towards the normal as the velocity decreases. Right. Oh, light bends towards the normal as the velocity decreases. Now what happens if the tractor enters in the same way? Directly perpendicular to the road. In that case, the right and the left wheel जो wheels आप देख रहे हो, the right wheel as well as the left wheel, they are having the same speed and the tractor is going straight without bending. So in the case of the light also, if the ray of light is going to travel straight, that means normal to the medium, then in that case it will not bend. So rarer to denser जाएगा तो towards the normal जाएगा, denser to rarer जाएगा तो away from the normal जाएगा. Light will travel straight, there will be no deviation if it is traveling normal to the surface. Okay, now what happens when the light travels from rarer to denser? Let us take more example. Let us take the case of air and water or glass. Then we know that the ray will bend towards the normal, right? Now velocity is decreasing, right? Now when it travels from denser to rarer medium, take the water or glass, the first medium, and air is the second medium. Draw the normal and you can see that the ray of light bends away from the normal. So this is happening because the speed decreases the velocity. It happens that when it travels in water it is less, and when it comes to air its velocity increases. Okay, now along the normal what happens? Any medium, if it is traveling from rarer to denser or from denser to rarer, and if it is along the normal, that ray will pass undeviated, right? But if it is traveling from a rarer to denser medium, speed will decrease, right? The path will not change, but velocity will decrease. And if it is traveling the other way, that means from denser to rarer, the speed will increase, but the path will remain the same. Okay, clear? Please draw the diagram, roughly of course, right? Okay, let us now understand more about the laws of refraction of light. Now we already studied about the refraction of the light, and the definition here is on the screen. Let's talk about the laws of refraction. The laws of refraction says that the incident ray, the refracted ray, the yellow one, and the normal all will lie in the same plane. The second law says that the ratio of sine of angle of incidence to sine of angle of refraction is a constant for a given color and for given pair of media. This is also known as the Snell's law of refraction. Mathematically, if you write sine I, see this is I and this is R, sine I by sine R is a constant, and this is written as mu or sometimes n, that is the refractive index. So sine I by sine R is equal to refractive index. So this is the laws of refraction. It is also known as Snell's law because it was given by the scientist named Snell, right? Okay. Now let us understand in the case of ice. If the light enters ice, then we will have the sin I by sin R is equal to 1.31. Diamond, if the light enters diamond, the refractive index here it is equal to 2.42. Now let us talk about the refractive index. How many types of refractive index do you know? We know that sin I by sin R is equal to refractive index. Right? That is new. That is n to 1. That means the light is traveling from first medium to the second medium, and we say that the refractive index of the second medium with respect to first, 2 with respect to 1. The light is traveling from 1 to 2, but refractive index is that of the second medium with respect to the first medium, right? So here that is equal to the velocity of the light in the first medium divided by velocity of the light in the second medium. It is also equal to sin I by sin R. ठीक है, दोनों का वैल्यू सेम ही आएगा, right? Okay, now talk about N12. N12 means the first medium is 2 and the second medium is 1. That means the light is traveling ulta. That means it is traveling from medium 2 to medium 1. In that case, we will have to write the refractive index is velocity of the light in the second medium divided by the velocity of light in the first medium. Now, what is the relation between them? They are reciprocal of each other. That is, N21 is equal to V1 by V2 and and 1, 2 is equal to V2 by V1. Basically, you can see that it is reciprocal of each other, right? So we can also write N of 2, 1, yeah, mu of Q1 is equal to 1 upon N of 1, 2 or mu of 1, 2, right? Okay. Now we'll talk about the absolute refractive index of a medium. Suppose the refractive index of first medium is vacuum, right? Suppose we take the first medium as the vacuum and the second medium as anything other. Suppose we have taken here as air, the first case. So light is coming from vacuum, hitting the air medium. It will go towards the normal refractive index is equal to 1.0003. Now, that of ice, if we talk about, it is coming from vacuum and entering the ice. Here the refractive index 1.31 absolute refractive index क्योंकि पहला medium is equal to vacuum, right? Then we come to water. The refractive index of water, absolute refractive index of water is 1.33. Now that of the crown glass, the absolute refractive index is 1.52. And if it is a rock salt, so in that case, it is equal to 1.54. And if you have got diamond, the absolute refractive index is 2.42. What does this mean? Hmm? Refractive index increases, the bending capacity also increases. जिसकी refractive index कम है वो कम bend हुआ, जिसकी refractive index जितना ज़्यादा है उसकी bending उतना ज़्यादा होता है. More the refractive index, more is the bending. ठीक है? Refractive index of diamond is equal to 2.42. What is the meaning of the statement? The meaning of the statement is when the light enters from vacuum to diamond, the speed of light is reduced by a factor of 2.42 as compared to that of the light. 2.42 times कम हो जाता है. That is the meaning of refractive index. Okay. Now, if you want to write the formula for the refractive index, we know that absolute refractive index of air. So, refractive index of air with respect to vacuum, that is the speed of the light in vacuum divided by speed of light in air. Now, if I write refractive index of ice with respect to air, so that means velocity of light in air divided by velocity of light in ice, right? Now, if you talk about the velocity or refractive index of glass with respect to vacuum, so it will be the velocity of light in vacuum divided by velocity of light in glass. Then we have got the refractive index of water with respect to air. So it will be velocity of light in air divided by velocity of light in water. Velocity of oil with respect to air, that will be velocity of light in air divided by velocity of oil in air. Okay, this is the way how I write. In your book, it may be given as mu, right? Okay. Now the formula for the refractive index, when the light goes from the first medium to second medium, it is velocity of light in the first medium divided by velocity of light in the second medium. And if it is 2, 1, it is 1 upon mu 1, 2. Velocity of V1 is the velocity of the light in the first medium. V2 is the velocity of light in the second medium. Important points to note that if the first medium is not mentioned, please take it as A. If the first medium is vacuum, then the refractive index of the second medium is called as the absolute refractive index. And for solving the numerical problem, velocity of the light in air, velocity of light in vacuum, take it as 3 into 10 to the power of 8 meters per second. And we will do the numericals. And also, yes, please remember, the refractive index has got no units. Okay. The first question we have, the light enters into a glass plate having an absolute refractive index of 1.50. What is the speed of light in the glass? Speed of light in vacuum is 3 into 10 to the power of 8 meters per second, right? So velocity of light in vacuum, we know that it is 3 into 10 to the power of 8. Absolute refractive index is 1.50 to find velocity of light in glass. Okay, complete formula में बैठाएंगे. Refractive index of glass with respect to vacuum is velocity of light in vacuum divided by velocity of light in glass. Put the values. Velocity of light in gas is equal to velocity of light in vacuum divided by refractive index. So, put the value. The speed of light in glass is 2 into 10 to the power of 8 meters per second. Simple, simple, simple question. ठीक है, चलिए नोट कर लो. The next question we have, the refract index of water is 4 by 3 and speed of light is 3 into 10 to the power of 8 meters per second. Find the speed of light in water. Refractive index of water with respect to air, it is given as 4 by 3. Speed of light in air, that is given as 3 into 10 to the power of 8 meters per second. Find the speed of light in water, put the formula, substitute the values. Mu is equal to 4 by 3, Va is equal to 3 into 10 to the power of 8. Velocity of light in water, just calculate, it becomes 2.25 into 10 to the power of 8 meters per second. है ना? Calculation सही है ना? ठीक है, note करो, note करो. चलो, let's do the next question. Refractive index of water for the light going from air to water is 1.33. What will be the refractive index for the light if it is going from water to air? भाई reciprocal होगा. हाँ. So we know that refractive index of air with respect to water is equal to 1 upon refractive index of water with respect to air. Just take the reciprocal. So the refractive index of air with respect to water, it is 0.75. Just reciprocal. Okay. Now the next question. Refractive index of kerosene, turpentine and water are 1.44, 1.47 and 1.33 respectively. In which of these materials light travels faster? लाइट ट्रैवल फास्ट होता है जिसका रिफ्रैक्टिव इंडेक्स कम होगा. तो आप क्या देख रहे हो, केरोसिन, टर्पेंटाइन एंड वाटर. Water has got the least refractive index, so the speed of light will be maximum in water, right? Okay, so we will have the refractive index less, so we will have the light fastest in water amongst the three given medium, right? Okay, and which medium the light moves fastest? Water, the refractive index is 1.33. Ice, the refractive index is 1.31. Alcohol, it is 1.36. Using the above table, calculate the velocity of light in water. दो चीज करनी है. तो सबसे पहले तो हम बता दें the refractive index of ice is the least. So light will move fastest in ice. Okay, that is the first part of the question. The second part is very simple. Velocity of light in water is equal to velocity of light in air divided by refractive index of water. So velocity of light in air, I said we will take it as 3 into 10 to the power of 8 meters per second. And refractive index is 1.33. Just divide it, you will get 2.25 into 10 to the power of 8 meters per second. Okay, fine. So let's do the next question. The path of the light passing from air to different medium A, B, C for a given angle of incidence is shown below. Study the diagram and answer the following question. In this question, we can see that the air is the first medium in all the three cases. There is medium A, there is medium B, and there is medium C. The light enters from air to the medium and the angle of incidence is 60 degrees. And angle of refraction for the medium A, it is equal to 30. Second case, the angle of refraction is 45. Third case, medium C, the angle of refraction is 40. तो अब हमें बताना है, answer the question, which of the media A, B and C has got the maximum optical density. बताइए, what is refractive index? Refractive index means it is sin I by sin R, right? तो sin R जिसका कम होगा तो refractive index उसका, यानी A has got the maximum refractive index. If the refractive index is more, that means the optical density is also more. So we know that optical density of A is the largest, then comes medium C, and then comes the medium B. So the answer is, we know that sin 30 is less than sin 40, is less than sin 45. So refractive index of A greater than refractive index of C is greater than refractive index of B. So medium A has got the maximum optical density, the second part of the question, through which three media the speed of the light will be maximum. The speed of the light is maximum, whose refractive index is minimum. So refractive index minimum किसका आया है? That is B का. So the speed of light will be maximum in the B of the lowest refractive index is equal to mu B. Now the third part of the question, will the light traveling from A to B bend towards the normal or away from the normal? देखो, ए से बी में जा रहा है, तो आपने देखा कि ये रेयर, ए जो रहेगा डेंसेस्ट मीडियम है, और बी सबसे कम वाला जो मीडियम है, दैट इज उसका रिफ्रैक्टिव इंडेक्स सबसे कम है. तो लाइट इज ट्रैवलिंग फ्रॉम ए टू बी, दैट मींस इट इज ट्रैवलिंग फ्रॉम डेंसेस्ट रेयर, राइट. सो डेंसर टू रेयर, इसका मतलब क्या होगा? हाँ, इसका मतलब क्या होगा? तो इट इज बेंडिंग, बोलो, denser to rarer, away from the normal. You are correct. Okay. So this is slightly tricky question. Yes, in board exam आएगा, ऐसे वाले questions आएगा. Prepare कर लेना. Okay. So thank you so much. Now there'll be more on the refraction of light and also the lenses. We will be doing all the questions one by one. Thank you so much.